Then the next thing for me to do now is to reduce the number of my carbon into 3. I mean my chain, the parent chain, into 3, such as what? Propane. So then I'm going to have 2 carbon atom left. So now let me reduce it to 3 into 1, 2, 3. Can you see that now? That means I have 2 carbon atom left. So having 2 carbon atom left, then I will now be shoveling the 2 carbon atom with those longest chain, which is 3. So I'll be shoveling them. So I'll be shoveling the 2 carbon atom into those 3s. Now let me start. Let me assume if I put, don't forget that the 2 carbon atom will stand in form of one will be methyl, the other one will also be methyl. So if I say I put the first one here, CH3, and I put the second one here, CH3. Please take note that the remaining places hydrogen occupied them, which is here hydrogen, 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 hydrogen. If you still count number of hydrogen, it will not change as 15. 12 rather, 12. And if you still count the number of carbon, it will not still be more than 5. Now, those are the hydrogens and the number of what? Carbon. It doesn't change. It's still 5 and 12. You can see the molecular formula up there. Still 5 and 12. So now, let us name this. If you are to name this now, you realize that the naming will still be what? 2-methyl-butane. 2-methyl-butane. Why? Look at the naming. 1, 2, 3, 4. That's my longest. Can you see it? 1, 2, 3, 4. That's my longest carbon atom. That's my longest chain. 1, 2, 3, 4 is the longest. Can you see? 1, 2, 3, 4. That's the longest. I hope you can see it. 1, 2, 3, 4. That's the longest. So why this particular one will now serve as the word substituent like that? This one is now the methyl now, because the chain is what? 1, 2, 3, 4. Can you see that? So this particular place where I wrote CH3, most students will think that is methyl. No, you cannot assume it is methyl until when you have confirmed your longest chain, which is known as a parent chain. So therefore, this is now my substituent now, because of the chain did not go alongside with this particular carbon here, but it goes together with this. Don't forget that if I'm splitting this CH3, it will be 1 year, 1 year, and 1 year. So naming that will still be 2-methyl-butane. Just follow the way I named this one compared with this. You understand that it is still 2-methyl-butane. So therefore, isomers cannot form like this. And by the way, if I also put the 2 carbon atom that is left out, if I put 1 year, 1 year, 1 year, 1 year, can you see that? Maybe this particular one is not here now. So if I should put it here, if I want to name it, the chain will be what? 1, 2, 3, 4. Can you say that now? 1, 2, 3, 4. So this one will still stay as the substituent, and that is still 2-methyl-butane. 2-methyl-butane. I hope you are following the procedure. Now, if I still put this my CH3, I put 1 here, 1 up here. Do you know that I can put 1 up here too? Or maybe here, let me assume here. CH3 is here. Can you see where I'm pointing at? Here, this particular place. And hydrogen occupies here. Hydrogen occupies here. Hydrogen is here, here, and here, and here. So I only put my CH3 this place and this place. This place and this place. So putting it here and here. Now, let's name that. The name will be what? It will still be 2-methyl-butane. You can check it out. Take your pen, check it out. Use the idea to name it out. Take your pen, draw it out, and try it. Give it a trial. Okay, so I said I've put it here, See the same thing, 2-methyl-butane. Then which other one again? I've put it here and here. Up here and here, still means the same thing. If you put it here and you put it here, you are still referring to the same thing. Please, you are still talking about the same thing. If your CH3 is on top of this carbon here and it's not in the front, it's still the same thing. Okay, so now the next thing for me to do is to put my carbon my substituent here and also the other substituent here. Let me draw that out. Then that will be, let me draw it here, 1 2 3. Can you see that? So here. Let me put it CH3 here and CH3 here. Don't forget that hydrogen are in the rest. Okay, now let's look at that. Looking at that, now let's name that. You can see that what I've been drawing so far, the structure are changing and the molecular did not, the molecular formula doesn't change. They still remain carbon atom of 5 and hydrogen atom of what? Of 12. So carbon atom of 5 and hydrogen atom of 12. So now look, now let's name that. Naming this now, our longest carbon atom is what? See it here is 3. And where is the 3? You can say 1 2 3 like this, and if you like, you can say 1 2 3 like this. Even you can still say 1 2 3 like this, like this. Can you see? 1 2 3 like this. You can still say 1 2 3 like this. Anyhow you want to take your 1 2 3 like this, you can see it's still 3. So our parent name is what? That is propane. That is 3. Fine. Now let me make things easier. Let me take our CH3 like this, our longest, our 3 number of carbon straight like this, and that happens to be our parent chain, which is propane. Propane. Now let's determine the substituent attached to that propane. So far, this is our carbon 1 2 3 or Craventure 1 2 3. It can come like this or come like this. What will make us to know whether it's going to come like this? Maybe 1 2 3 will start from here, or 1 2 3 will start from here. That determines, that depends on our what? On our substituent, where our substituent is located. Substituent can be methyl, ethyl, anything apart from hydrogen is substituent. Apart from hydrogen, any other thing apart from hydrogen is a what? Is a substituent. So this happens to be our substituent CH3. This one is our substituent CH3. Please, I did not put the hydrogen because of time. So assume that hydrogen atom is there. Now let's now name this. Now we have two substituents here and here. Okay, so I should start my naming from here. 1 2 on carbon 2. I have here. If I start from here, 1 2 on carbon 2, I still have here. So that means I can actually start my substituent from where? From anywhere. I can start my counting from anywhere. I can either start it from here, 1 2, and also I can also start it from here as 1 2. Do you see that now? So now let's name that. Now let me start from here. As 1 2 3. Okay, so on carbon 2, I have what? 2 methyl, or some people call it methyl. 2 methyl. So writing this down will give us what? 2 methyl. Sorry, you have how many methyl? 2 1 1. That will be 2 dimethyl. 2 dimethyl, because methyl is what? Is 2. Di, the prefix. 2 dimethyl propane. 2 dimethyl propane. 2 dimethyl propane. So that is the name of this particular structure. 2 dimethyl propane. So now you can see that we now have 3 different names. What are the 3 different names we have? We have the name of propane. Pentane rather. Pentane. We have the name of 2-methyl butane, and we also have the name of what? 2 dimethyl propane. That is how many? That's it. This is the third one. Yeah, this is the third one. So now, how can we determine whether we are done or we still have more isomer. Don't forget that while fixing these two that is out here, these two substituents, or this one, anyone you wish to use, let's assume that these two. So while fixing out these two substituents, or you can use here to anyone you prefer to use. So these two substituents, I've put it here, I've put it here, I've already shown it here now. So the next for me to do is to show it here and here. If I show it here and here, don't forget that it will still give me the same naming when I was putting, the same name when I put it in this place and this place. This place is the word starting point. This one is also the word starting point. So you get, so the name will still be the same thing. So looking at this, pentane has 3 isomers. Pentane has just 3 isomers, and these are the 3 isomers of what? Of pentane. These are the 3 isomers of pentane. You cannot reduce the number of carbon of the parent chain to 2, because if you reduce it to 2 and you start fixing the remaining 3 carbon atom that is left, if you start fixing it here and there, you will notice that all the naming you'll be getting, it will still be within 2,2-dimethyl propane and 2-methyl-butane. You will not get any other name aside from these two. Or peradventure, you might eventually even get pentane set. So the minimum limit which you can reduce your parent chain to is 3. Even if you are doing for hexane, even if you are doing for octane, nonane, decane, kene 2, under alkene 2, anyone you are doing for, when you get to 3, after fixing everything, you stop in 3. Because if you should proceed in 2, you will see that you will still end up getting the same name of what you have been getting before. So that is that about pentane. That is everything about determining the isomers of pentane. So in a nutshell, pentane has 3 isomers, and they are what? Number 1 is what? A normal pentane, which is this. Number 2 is what? 2-methyl-butane, and number 3 is 2,2-dimethyl-propane. Thank you so much for watching this video. Please, again, try to share this video to your loved ones. You can comment. If you have any question, the comment box is there for you to express your question into, and give us a like thumb. Thank you so much, and God bless you.